So we have a lot of people from model risk, model developer, and all of those things. So we cannot just put Arno creation on the wild, right, in banking. We have to make sure that it's not going to create reputation risks, it's not harmful, and we feel safe about it. And so do testing is very hard in GenAI. Unlike predictive model, when you have data that you can use to test it, in GenAI you have to create testing. And that's very, very expensive, very laborious, and all of those things. And even that, if we ask people, you ask, let's say, create for me 30 different prompts to test my RAG system, it will take forever. Okay, let alone we want to test it comprehensively in the entire space. So human is very valuable, but we need to augment human with automated testing. But we don't do automated testing in irresponsible way as well, because we need to do testing that is very, very, we can trust and reliable. So that's part of it, that we don't use LLM as a judge, unlike anybody out there that use LLM to judge what LLM does. We don't do that. That won't fly in regulated industry like banking. So we want to use something that's reliable. So I have I have a pleasure working with H2O and smart engineer in H2O. Srini is one of them, incredible talent. I recently retired from Wells Fargo, so and try to make model testing and model validation becoming more widely applicable, available for all of you. If some of you knows me, I release a tool that's called PyML that is used for model validation and model development about 2.5 years ago. Today's my co-developer sent me a message like 300,000 downloads. So thank you, many of you, that you all using it. And so now we're trying to make it into the GenAI world. Some of you have a flyer. In that flyer, it has 2 recent papers that I wrote. On the one on the predictive AI, the other one on the GenAI. The GenAI piece, we're going to have a workshop this afternoon, 6 hours workshop, how to do it in very hands-on. So visit the workshop. But I asked Srini here to give a quick demo, probably 5 minutes, what we do, what we're trying to do, what the GenAI validation looks like. First, is start with comprehensive generation of query. When we talk about that, query has to cover all the topic and need to generate all kind of query types. Yeah, so and this is very tedious. Generate all the topics in the system and all kind of query types. Then we run it. Then we evaluate it algorithmically, but we don't trust fully algorithmic evaluation. By the way, like I said, we used very, very transparent and explainable evaluation. We don't use LLM as a judge. Then we have small sampling for human calibration. We created calibration, then we can identify all the model weakness in terms of, I call it type 1 error. Type 1 error is hallucination. You say something that you're not supposed to say, false positive, which we all worry about. But the other side that for banking is very important, that don't get a lot of attention, is completeness. Think about if your GenAI summarize complaint and your summary is incomplete. So that's a very, very critical. Think about if your customer service using GenAI to help customer, and the information that given is not complete, but suddenly you violate UDAP law. Okay, so those kind of things that we're trying to do with this tool. So with that, Srini, because we have 5 minutes, okay? So why don't you, I turn it to you.
Thank you, Agus. So like Agus is mentioning, so I just want to take you through quickly to this notebook where we go step by step, the comprehensive question generation and validation, and then debugging and human labeling, conformal prediction. So here's this first step, so where we can generate a topic model, and then we can inspect the topics in the topic model, Here is where we can generate questions comprehensively from all parts of the topic model, right? So here in this example, we generated 844 questions automatically. And because we're using LLM to generate these questions, we want to independently validate those questions using NLP techniques. Then we can get answers for all those questions from that RAG that we want to test. Here we are testing our own RAG. Once we get the results, everything happens in the notebook automatically, right? There is experiment tracking and caching. And once we have those answers, and then we evaluate based on our 6 metrics here, right? So we can plot the distribution of all those results in these charts.
It's like there is a topic, right? Index.
Yeah. So then we can go inspect these results using this widget, right? So once we inspect and label them, then we create a conformal prediction sets, and then we can identify the threshold.
Show the debugging a little bit, going to the example debugging.
Okay, yeah. There we go. So this is the debugging part. So first we saying a lot of validations. They are saying, here's your, if you give us 1,000 questions, we will give you one average of all the 1,000 questions, right? Then we killed all the information there when we compressed all the data into one single number. So then we said average is no good. We want to see the entire distribution so we can find the outliers, and then we can find the weakness where the model breaks, right? As model validators, you want those edge cases. So when we plot the entire distribution, we found the edge cases, right? So, but edge case is still showing a point on the chart, some floating point number. What is the answer? What makes this low score? Why there is hallucination? Why there is irrelevant information, right? So we give you that answer really instantly here. So what happens is you can click some question that you're interested in here, and then that immediately refreshes this lower part of the screen of the widget, where you can see the entire answer on the left side. So you have the question you selected, all the answer is here, and then we are on the right is the context that was retrieved to answer this question, right? So we are showing you both the context retrieval validation and the generation validation in one view. So then you can see we color coded these lines based on where there might be hallucination, right? So we say we are saying some lines here are probably hallucination. Sure, it is in this case. You can quickly select those lines and see if there is any relevant context for this information provided by the LLM. So on the right, you can see whenever I go over any of these yellow lines, the context, the best thing we can find on the right is absolutely irrelevant, right? But if you go over some part, there is really high correlation. As human, you can verify that there is high correlation. So this helps you kind of debug and also do human labeling. So once you do label approximately 10% of your data, then we can say, okay, based on your labeling, based on your comfort level, this is your threshold. Here we found a threshold based on your input, based on human in the loop. Right? Thanks.